Hello friends, I am Ameya welcoming you to the Unacademy's doubt solving session. I am gonna help you to solve your all the doubts and as physics. Let's get into it. Okay, now let's the first problem. In photoelectric effect, the work function of a metal is 3.5 electron volt. The emitted electrons can be stopped by applying a potential of minus 1.2 volt. Then, option A, the energy of the incident photon is 4.7 electron volt. The energy of the incident photon is 2.3 electron volt. Option C. If higher frequency photon is used, the photoelectric current will rise. And option D. When the energy of photon is 3.5 electron volt, the photoelectric current will be maximum. Okay, let's see the solution. Okay. First, we have given the work function psi of a metal is 3.5 electron volt. Work function is equal to 3.5 electron volt, and this is our first entity. And the another point they had given, the stopping potential is minus 1.2 volt. Stopping potential is equal to minus 1.2 volt, and this is our second entity. Okay. Okay. Now look into the concept. Consider the single CRT. Okay. Look. This is the single CRT, and where two photosensitive plates are connected with the small battery or cell. The two photosensitive cells, the photosensitive plates are connected with the small battery or cell, where one is a negative terminal and one is a positive terminal. Here A and B electrode. Okay, when this is a negative terminal, this is a positive terminal, so plate A gets negatively charged and plate B gets positively charged. Okay, when now look into the diagram. When incident ray of light falls on a plate A, when incident ray of light falls on a plate A, it emits electron, it emits certain amount of electrons and completes its octet state. Okay, and this emitted electron will move from plate A to plate B. Emitted electron will move from plate A to plate B. Okay, and thus current flows through the circuit, and thus current flow through the circuit, and so it satisfies the Einstein's photoelectric equation. That is Einstein's photoelectric equation, it satisfies, and that is energy h mu is equal to h mu naught plus kinetic energy. This is the Einstein's photoelectric equation, where h mu is the incident energy, h mu naught is the initial or threshold energy, and Ke is the kinetic energy. So according to the given data, we know the value of h mu naught. We know the value of h mu naught, that is work function is equal to 3.5 electron volt. Sorry. Now we will see what is the kinetic energy. We will see what is the kinetic energy. Consider the same CRT. Consider the same CRT, but carefully look into the diagram. Here two electrodes or two photosensitive plates are placed, but carefully look the diagram. What we did, we reverse the battery or cell terminals. That is, plate A gets positive terminal of battery or cell, or plate B gets negative, and plate A gets the positive terminal of the battery. Okay, then what happens to plate B? Gets negatively charged and plate A gets positively charged. Now when the incident ray of light falls on the plate A, this incident ray of light falls on the plate A, it will emit some certain amounts of electrons. Okay, but the problem is the plate B also gets negatively charged, and electron has also negative charge, electron has also negative charge, and plate B also gets negatively charged. So electron gets repelled because negative negative gets repulsion. So electron does not uh, reach to the plate B. Now listen carefully. Following is the most important concept. Listen. प्लेट ए से प्लेट बी की ओर, प्लेट ए से प्लेट बी की ओर जब इलेक्ट्रॉन मूव होगा तो उसके मूवमेंट की एनर्जी को हम काइनेटिक एनर्जी बोलेंगे, और वो काइनेटिक एनर्जी कितनी रहेंगी? हाफ एम वी मैक्स स्क्वायर. द काइनेटिक एनर्जी विल बी, काइनेटिक एनर्जी will be half mv max square. Now because of the reversal of the battery terminals, plate B got some stopping potential. Because of this reversal of the battery terminals, plate B got some stopping potential. The stopping potential provided by our battery should be equal to the kinetic energy of the electron. The stopping potential, so stopping potential is equal to kinetic energy of the electron. Stopping potential of the battery is equal to kinetic energy of the electron. Now what do you mean by the stopping potential? Okay, stopping potential, what do you mean by this stopping potential? Okay, now कंसिडर फॉर एग्जाम्पल, अगर मूविंग इलेक्ट्रॉन, ये जो मूविंग इलेक्ट्रॉन है, हाँ ये जो मूविंग इलेक्ट्रॉन है, तो मूविंग इलेक्ट्रॉन की काइनेटिक एनर्जी अगर 2 यूनिट है, दिस मूविंग इलेक्ट्रॉन की काइनेटिक एनर्जी 2 यूनिट है, तो स्टॉपिंग पोटेंशियल भी 2 यूनिट होना चाहिए. स्टॉपिंग पोटेंशियल भी 2 यूनिट होना चाहिए. Otherwise electron will reach at plate B or point B slowly. So the kinetic energy is equal to half mv max square is equal to stopping potential. So again the kinetic energy of stopping potential is equal to, kinetic energy is equal to the stopping potential. Okay, and due to the negative charge we will take its modulus. So stopping potential is equal to kinetic energy is equal to, because of the negatively charged, modulus of 1.2 volt is equal to 1.2 volt. Okay, so we got the second entity also, and this is over the second entity is equal to 1.2 volt. Now we will see the problem, that in problem h mu is equal to h mu naught plus stopping potential or kinetic energy. So after putting the all values here, h mu naught is equal to 3.5 electron volt plus stopping potential is the 1.2 volt, and total energy is equal to 4.7 electron volt. Now back to the question. Option A, the energy of the incident photon is the 4.7 electron volt. So option 1 is the correct answer. Okay. Now let's see the another question. The stopping potential V0 versus frequency V, plot of a substance is shown in a figure. The threshold wavelength is option A 5 into 10 raised to 14 meter, option B 6000 Armstrong unit, option C 5000 Armstrong unit, and option D cannot be estimated from given data. Okay, now let's check the solution. Okay, as we have discussed in earlier problem, Einstein's photoelectric equation. Einstein's photoelectric equation is equal to h mu is equal to h mu naught plus kinetic energy. This is the Einstein's photoelectric equation, but we know the kinetic energy should be same as the stopping potential. Kinetic energy should be the same as the stopping potential. So we can say that the graph is a plot between frequency on x-axis and the kinetic energy or stopping potential on the y-axis. So from graph we can say that this is the x-axis and this is the y-axis. So on x-axis we can plot frequency, and on the y-axis we can plot the stopping potential. Okay, so what is meant by the threshold wavelength? So what is meant by the threshold wavelength? Basically it is the cutoff energy to emit the electron. Threshold wavelength is equal to the cutoff energy to emit the electron. Now back to the data given in the problem. Here we know the value of frequency. Here we know the value of frequency is equal to 5 into 10 raised to 14 hertz. This is the value of frequency given in the problem. Okay, and we know the formula, that is C is equal to mu lambda, where c is the speed of light, mu is the frequency, and lambda is the wavelength. So lambda is equal to c upon mu. Now putting all values in that formula, we will get lambda is equal to value of c is equal to, it is a constant, 3 into 10 raised to 8 meter per second, and value of mu, that is frequency, is a 5 into 10 raised to 14. Now after solving this we can get 0.6 into 10 raised to minus 6. Again solving we got 6000 into 10 raised to minus 4 into 10 raised to minus 6. Further we get 6000 into 10 raised to minus 10 is equal to 6000 Armstrong unit. Now check the answers. Option B 6000 Armstrong unit, and it is the right answer. Okay, now let's take the another problem. Okay, which one of the following graph represents the variation of maximum kinetic energy Ek of the emitted electrons with frequency mu in the photoelectric effect correctly? Okay, now check the solution. Okay, as we have discussed earlier, the Einstein's photoelectric equation, is h mu is equal to h mu naught plus kinetic energy, where h mu is the initial energy, h mu naught is the threshold energy, and kinetic energy. Now we know that the kinetic energy is equal to h mu minus h mu naught. Okay, kinetic energy, and this is important formula. Kinetic energy is equal to h mu minus h mu naught. To gain the kinetic energy to the electron, the initial energy should be the more than threshold energy. The initial energy h mu should be strictly more than the threshold energy h mu naught. Example, मतलब consider अगर electron needs 2 unit. Okay, let us take an example. If an electron needs 2 unit of a energy to move, but the threshold energy is lesser than 2 unit, but the threshold energy, that is h mu naught, is lesser than 2 unit, then it will not move, or it will be in the rest position. So initial energy should be strictly more than the threshold energy. Okay, so initial energy strictly more than the threshold energy. So after seeing the graphs of that shown in the option, we can conclude that the graph 4 or option 4 is the correct answer. Okay, thank you.